All right, linear application number 4, taking an Uber. What's an Uber? Oh, I know what an Uber is. It's just kind of a funny word. So Uber, it's kind of like a taxi. You may have heard of it. Or Lyft. Lyft is another brand of the modern taxi. Okay, so it says when you don't have a ride to where you need to get, you can almost always get an Uber or Lyft, or if you're really old school, you can call a taxi. But not all rides are created equal. Sometimes you'll need a short ride that doesn't cost much, and sometimes you'll need a longer ride that is usually more expensive. Suppose a passenger, maybe it's you, in an Uber, has looked at the cost of their rides. A ride that went 4 miles cost $12.05, while a ride that went 7 miles cost $19.40. Assume the cost per mile is the same. So that little statement at the end there, that makes it linear when the cost per mile is the same. Okay, so we just need to come up with 2 coordinates. So again, we look at kind of the important information here. There's one piece that's pretty important, and here's another one that's pretty important. Okay, so we can come up with 2 coordinates. So the first one I'm going to call 4, 12.05. Now this one's going to be interesting because of these decimals. And then the second one is 7, 19.40. Okay, so in this case, the x is miles, if we look at what we highlighted. So the x is going to be miles, and the y is dollars, or cost, right? So I'm just going to use a dollar sign. Why not? Okay, so it says calculate the equation of the line that represents the cost of a ride after a certain number of miles. So you should start to get used to this. 1, we find the slope. 2, we find the y-intercept. And then the third thing we do is we just write it out. Okay, so the slope, if you remember, we're going to take the y values and subtract them on top. And so I'm going to go ahead and do that. So I'm going to say m equals 19.40 minus 12.05. And then on the bottom is where I'm going to put my x values. And again, just like in Grandma McGregor's cookies and any other application problem that we do, we always want to start with the same point. So we started with 19.4 on top, so we're going to start with the 7 on the bottom. So we're going to say 7 minus 4. Okay, you'll notice that this slope is going to end up being positive because the cost per mile is going up, right? So your cost, or your total cost, is going up. So each mile that you go, it costs you more money. So that's why it's a positive slope. So we're going to simplify this. $19.40 minus $12.05, that's $7.35. So I'm going to write 7.35 divided by 3. All right, anytime we have a kind of a funky decimal for our slope, I'm going to go over to my calculator and see if that thing simplifies to a nice neat decimal. So I'm going to go over and say, does 7.35 divided by 3 equal something nice? And the answer is yes. 2.45 is a nice decimal because it stops. It doesn't keep going. Okay, so I'm going to go ahead and simplify my slope to 2.45. All right. You know, while I'm at it, I'm going to go down to the next one. I'm going to go down to E. Since I just found my slope, I'm going to say, hey, it says, what is the slope of your equation? It's 2.45. What does the slope represent? The slope represents the cost per mile. Okay, so it's $2.45 for every mile that you're in that Uber. Oof. That can get kind of costly if you go a long ways. All right, so now we're going to come back up here and we're going to find the y-intercept. Okay, so y equals mx plus b. Okay, I found my slope. I'm going to pick one of these points. I kind of like the first one better, so I'm going to go with this one and say this is my x, this is my y. I'm going to say 12.05 equals 2.45 times 4 plus b. Well, 2.45 times 4. Well, let's go over to the calculator. 2.45. We can be a little sloppy and see if it does it. Look at that, 9.8. Perfect. So this is 12.05 equals 9.8 plus b, and then I'm going to subtract 9.8. I think I can do this one without using the calculator. It's going to be $2. I say dollars. It's going to be 2.25. I think. But you know what? Let's go to the calculator. 12.05 minus 9.8. Let's do it that way and see if it does it. Nope. Let's do it this way. 12.5 minus 9.8. 2.7. Whoa. Oh, no, it's not 12.5, is it? It's 12.2. No, it's 12.05. Oof, what am I thinking? So we got to fix that. Trying to remember stuff. 12.05 minus 9.8. There we go. I was right. 2.25. Okay, so we have 2.25 equals b. So that's my y-intercept. Okay, so while I'm at it, before I even write the equation, I'm going to go down there. It says, what is the y-intercept in your equation? 2.25. 2.25. What does the y-intercept represent in this problem? Now, this one's a little trickier because we're talking about money. But remember, the y-intercept is always what happens at the very beginning. So what this means is that when you shut the door on the Uber, when you get in and you shut the door, before the car even moves an inch, it costs you $2.25. All right, so it's the initial cost of just getting in an Uber. So if you go 0 feet after getting in, you're going to pay $2.25. Okay? All right, so let's go back up here and write our equation. So I'm just going to say y equals 2.45x. Uh-oh, I'm not going to have enough room. Hold on. 2.45x. Let's see if I can do this. Try and move this over. Where can I put it? I'll put it right there. Plus 2.25. So this is a much different equation than what we're used to because both numbers are decimals. But that is totally fine if they are decimals. All right, let's go down here. We got some questions to answer. Calculate the x-intercept. So remember, the x-intercept happens when y is 0. So I'm going to take my equation. I better look at it again. 2.45x plus 2.25. So it's y equals 2.45x plus 2.25. Y is 0, so I'm going to replace the y with 0. Okay, that's a decimal there. I'm going to subtract that. Okay, so then I have negative 2.25 equals 2.45x. And then I'm going to divide by 2.45. So I'm going to have to go to my calculator because it's decimals. One of them's negative, so we have negative 2.25 divided by 2.45. Whoa, okay, so the 3 little dots here, that means that decimal continues on. And this is when we have to round. So if you were to see something like this when you're finding your slope or your y-intercept, then you would want to not use that decimal. So I can't even remember now what it was. I got to go back. 918. Remember that for me. 0.918. All right. If we think about what that means. X was what? X was the number of miles, right? And Y was the cost. So this is suggesting that when it costs $0, we've gone negative, we've almost gone negative 1 mile. Can you see why that's unrealistic? Because what we just talked about with the y-intercept, the minimum that it's going to cost is $2.25. And it's really unrealistic because they're not going to charge, or they're not going to go a negative distance, right? It's always going to be a positive distance. Okay, so this is unrealistic because this is a negative distance. And we don't ever go a negative distance. We can go backwards, but even if you go backwards, it still is considered a positive distance. Okay? All right, so that's why it's unrealistic. Okay, couple of questions here. How much will a ride cost if you need to travel 13 miles? All right, so miles was X, right? So that means X equals 13. And I can go ahead and plug that into my equation. And I'm using the equation that I can see up above there to do this. So I just plugged my X value in for X. And I can't do 2.45 times 13 in my head, so I'm going to go to my calculator. 2.45 times 13. 31.85. So we got to go over here. And so that Y equals 31.85 plus 2.25. Oh, I might be able to do this one in my head. Y equals, it's going to be 34.10. Okay, so dollars, right? So your ride is going to cost $34.10 to go 13 miles. Yikes, that's expensive. All right. So now, next one, H, we want to say, hey, if a ride cost $42.92, how far did this ride take you? So remember, cost is Y, so Y is 42.92. So again, I'm just gonna use the equation over here on the left where I have the 13, and I'm not gonna write the 13. I'm gonna write that as an X. But since Y is 42.92, I'm gonna start with 42.92 equals 2.45x plus 2.25. Okay, so we got some subtracting to start with. Minus 2.25. Oh, I might be able to do this one. So this is going to be 40.67. Okay, if you want, let's go do the calculator. 42.92 minus 2.25. See if I'm right. Dang, 40.67. All right, equals 2.45x. Divide by 2.45. Notice how we're doing the exact same thing for all these. When we have the y, we're adding or subtracting something, and then we're dividing by something. All right, I can't do this one in my head, so let's go over and do 40.67 divided by 2.25, and let's hope it's a nice, neat number. It's not. Okay, it's got the little ellipse there. It's called the 3 dots. That means it continues on forever. And so we're just going to say 18.075. Now, if we think what we're talking about here is we're talking about miles, right? So we could just say, we could do a little rounding here. That 18.075 would actually be 18.08. Or we could even go so far as to say, yeah, that 0.075, that's not a very far distance, so let's just call it 18 miles. All right, so we're going to say x is equal to 18 miles. All right, graphing. I believe that's next. Yes. Okay, so we're going to go back to Desmos and graph. I have to remember the equation. 2.45 and 2.25. All right, here we go. So let's go to Desmos. And we'll just clear these by hitting the X in the corner. So I'm going to type in my equation. So it's y equals 2.45. I'd forgotten what it was already. X plus 2.25. Where's my graph? I can't see it. So, oh, look at this one. It's going the other direction. It's going up. It's because it has a positive slope. All right, and then I'm going to go ahead and open up this and go look and see what numbers do I need to put in there. So I need to go from -5 to 25 and -10 to 100. So I'm going to change that. Here we go. -5 to 25. -10, was it? Now, if you're not exact on these numbers, it's not a big deal. There we go. We can see our graph, and that's important. And you can notice that y-intercept is just above the 0 down there. And that's because of that $2.25 that it costs a minimum cost to take a ride. Okay, so then we need to add some points here. And I don't remember what they are off the top of my head. So I got to go back and look, and we're going to add those points from the very beginning that we found. Ooh, 4 and 12.05. And 7 and 1940. 4, 12.05. And this is a good test because do they show up on the graph? 7 and here I've already forgotten this one, I think, but 7 and 19.40. Was that it? Here's the moment of truth. Ooh, that one's on. I can see it. Yep, they're both on. So there we go. Ooh, I need to change something that I didn't change. Notice how it says minutes and degrees on our graph. We need to go back over to the wrench and change this one. So X was miles and Y was dollars, right? So, ooh, we could go find the dollar sign maybe and use that. There it is. Let's use that. And we should be good. There we go. There we go. So now you can see we got miles down on the x-axis and dollars on the y-axis. Okay, so you need to screenshot your graph and paste it into the Notability document. And so you're getting some good practice in doing this.